Hello, everyone. My name is Vitek Bedik, and I will give you a project overview and project update on Monasca. So what is Monasca? It stands for Monitoring as a Service. It offers an API to control the whole monitoring system, starting from measurements collection, querying the measurements, defining the alarm definitions and notification methods. You've got all the means to build your own monitoring system for operator and for the user of OpenStack. Monasca is multi-tenant, so there is a clear isolation of every data in every project, measurements, and also alerting rules and notifications are stored per project. We implemented the solution to be highly performant. We achieve it by using components like Apache Kafka, which is very well suited to pass the measurements in a very performant way in high loads. It also helps to implement such features as high availability, fault tolerance, and scalability. It can replicate the messages. It can cache the messages in case of some network problems. It also allows to add consumers to the message queue so you can scale your system. Monasca implements the push monitoring model, meaning the agent installed on the monitored system is responsible for actively pushing the measurements to the public API. And we have the ambition to be something like equivalent of Amazon CloudWatch in OpenStack, including support for logs and events. So here's a quick overview of our architecture. With the API as the first interface for the user to control all the system, the messages are then passed to the message queue, which is responsible for communication to the specialized services, for example, for persisting or notification engine. A little background about the project. It was founded in the Liberty release cycle of OpenStack. In the last Stein release, we had 55 individual contributors. And we have around 10 to 15 constant developers working on the project. The adoption is not too high. Here are the numbers from the last user survey, but they are constantly increasing. The main companies contributing to the project are Fujitsu, SUSE, Stack HPC, also NEC, and recently also Inspur from China. I've been many times asked, why do we actually have 2 monitoring projects in OpenStack, and why at all do we have monitoring projects in OpenStack? You can use Prometheus. It is very widely used. Why don't you take Prometheus to monitor your OpenStack? So I have listed here some criteria, similarities and differences, and want to shortly go through them. So let's start with the monitoring model. Prometheus implements the pool model. So it is the server is it comes from the Kubernetes world. So you have a single Kubernetes cluster with a single Prometheus server, and it automatically detects all the containers with their endpoints and pulls the measurements from these endpoints in an automatic way. The limitation is when the network architecture or you have more clusters, not always you can reach all these endpoints. So you will have to deploy additional servers in additional clusters. Push model is in that aspect more universal. you expose the public API, and the agent installed on the monitored system is responsible for pushing the measurement. So it's easier to achieve that in the complex architecture. Another difference is in the push model, you have the possibility to retry the request. If for some reason you have some network failure, you cannot reach the API. In the Monasca agent, we have a caching mechanism. If the request fails for some reason, you can retry it. And so we can guarantee that the message has achieved the monitoring system. Monasca is multi-tenant, as I said. We isolate all the messages per project, also alerts and notifications. Prometheus is, that's out of scope for Prometheus. Prometheus does not care about multi-tenancy. HA and scalability is well implemented in Monasca. In Prometheus, it has been thought as a single node monitoring tool. You can set it up in the highly available and scalable way. I will explain how you could do this, but there are some limitations. And also, if you talk about the scalability, it means something different for Monasca and Prometheus. I have mentioned before, in the pool model, you have to have one server in one cluster and one network. If you have more networks, more clusters, you usually need more instances. In Monasca, you won't have to scale that quickly. You're only limited about on the performance of the system. Okay, the next aspect, historical data. Prometheus is designed to store like 1 week, 2 weeks of data. There are ways to increase that, for example, by remote write mechanism, where you can add external storage to Prometheus. But it also has limitations when used at scale. Alerting. In Monasca, we have the API, which controls all the alerting rules for every project, similarly as in the telemetry. In Prometheus, all alerting rules are defined statically in YAML files. So it's not really useful when you want to offer monitoring service. To be fair, the alerting manager capabilities of Prometheus are much richer than these of Monasca. You can do much more things with it. Delivery guarantee, I have mentioned already. You can retry the requests in the push model. Monasca agent caches the failed requests, failed measurements. Another point where we add the resiliency is Kafka message queue, which also caches the measurement internally if you have the problems with the backend. High performance. Both Monasca and Prometheus are really high performant in contrast to telemetry, which has typical sampling rates of like 10, 15 minutes. Monasca Prometheus, it would be like 15 seconds. Query language. Prometheus has a very rich and flexible query language, which is really very nice. And finally, community adoption. Prometheus has a very large and active community. Monasca, rather small, but active community, and telemetry is in maintenance mode, I would say. A few words about how the Prometheus cluster can be set up. So if you want to monitor more than one clusters, you have to deploy separate instances for every of these clusters. And then in yet another cluster, you query all the measurements from these instances and configure the alerting manager and Grafana dashboards. And it works quite nicely. There are limitations, like, for example, you cannot aggregate measurements from different clusters. They are totally independent of each other. Also, when you grow and you operate at scale, at some point the maintenance is getting complicated. You get very many instances, and you have to maintain somehow all these alerting roles and target configurations. Also, for high availability, in every cluster you just deploy 2 or more instances of Prometheus, and so you duplicate the data. And the problem with this is there is no native way to actually deduplicate this data again in the final presentation. Also, the measurements are not really quite the same because the instances, they operate independently of each other, so you cannot really say that the measurements are consistent between each other. The alerting rules can even give different results from these instances. Okay, so short summary on these 3 projects. Prometheus, it's definitely first choice for operators when you don't care about multi-tenancy. You just want to monitor your infrastructure. And for rather small deployments, when you don't want to fight with the limitations of high availability and scalability when you operate at scale. Monasca would be your choice if you want to offer monitoring as a service for the OpenStack users, not only for operators, but also for users. When you want to allow them to create their own alerting rules and integrations with OpenStack, for example, auto-scaling, what we presented today in the workshop. It would be a better choice if you have large deployments because it scales more easily. There are some special cases when you really care about the push model, when you have some, for example, short-lived jobs which cannot be good monitored with Prometheus, or you have irregular metrics. Another point would be delivery guarantee, where you have some important measurements like billing data, for example, or some scientific measurements. Historical data. InfluxDB can efficiently query very old data, like for months ago and even years ago. And last but not least, Monasca can also scrape Prometheus endpoints, so you can all the measurements which you can get with Prometheus exporter or Prometheus instrumented applications, you can also collect with Monasca. By the way, it can also collect the ceilometer measurements. Finally, the telemetry projects, I would actually recommend it only for users who already have it deployed, and only for billing and metering use cases. That's also what Red Hat is telling in their presentation. Now, let's move to the work we have done in the Stein release. So that was not much of the new functional work. We rather concentrated on consolidating what we have and on the manageability and usability of the project. So we have worked on creating Docker images in OpenStack CI. So all the changes now are automatically taken to the image build process. Then the second task we have started working on is some major refactoring of the APIs and also merging, because we have till now 3 repos: metrics, logs, and events API. We want to unify it to make it easier to operate, and also by this opportunity reduced some technical debt in these repos. Then we started upgrading the Kafka client used in the services to increase the performance, and also some cleanup tasks like moving the built-in notification methods into plugins, or cleaning up the configurations and unifying the configurations of the individual services we have. Then, of course, we have worked on community-wide goals, like running all the all the services on the Python 3, and also implemented the pre-upgrade checks, which was the community goal in Stein. Possible features and enhancements for the next release is kind of difficult because we have not had the planning meetings yet, but from our discussions till now, the topics which you could find in the next release would be the new thresholding engine. We want to improve the query language to catch up on what Prometheus can do. Also, we would like to use the new capabilities of Keystone's application credentials. I mean the new access rules for application credentials in Grafana data source. Yeah, other points would be adding sharding support for InfluxDB in Monasca. Adding Monasca deployment to OpenStack Helm. That would be also good if we could tackle this and find developers working on this. We have some cross-project work which we have done till now. So I have listed some existing and planned or possible integrations. There are different ways how we can integrate. One is via alerting. One is via implementing the data source. So the data source meaning another service is querying the data from Monasca and uses it in some way. And Ceilometer integration is kind of different. Ceilometer can publish the measurements to Monasca API. So currently we work on integration with Vitrage. We will have a workshop tomorrow showing how we do it in our POC. It's work in development still. And I also want to have a look at integration with Zenlin. Perhaps it will be possible in the next release. So the release themes, possible release themes for the next cycle would, from my perspective, be manageability and user experience, first of all. And then, as minor focus, scalability, security, and interoperability. Please give your feedback. You can reach us at the mailing list, OpenStack Discuss, in the IRC channel, mostly in the European zone, but also there are some guys in US. And we have weekly meetings Wednesdays at 3 p.m. UTC. In OpenStack Monasca IRC channel. So please come and ask questions if you have any, and give feedback. How you can contribute. We plan our work in a Kanban board, in storyboard. The link I have posted is still empty, but we will have a planning meeting in the PTG, so it will fill up soon. You can also help on bug fixes. Cross-project work is important to us. We cooperate in the self-healing SIG and auto-scaling SIG, and we look for developers who would like to do such inter-project, cross-project work. It's difficult to find developers, so it's very welcome if you guys would like to help on this. Installers for Monasca, there are many ways how you can install, and we need help for this. For example, OpenStack Ansible installer is existing and functional, but people who were maintaining this are not working on this anymore. So we need help on this. If you work with OpenStack Ansible, there are these Monasca roles. Please stand up and help maintaining these. Documentation, of course, it's always difficult to find people working on documentation, so your help is very welcome. Monasca, in this summit, we will have onboarding session today afternoon in the room next to this one. Then we have tomorrow workshop integration with Vitrage at 9 a.m. And then a use case presenting deployment of Monasca in large scale. Tomorrow, 11:40. And then we have PTG sessions on Friday and Saturday later this week. That's all from me. Please, do you have any questions?
So how can we grab metrics from SNMP devices, like network devices, routers, switches?
We don't have, so the question was how we can collect SNMP metrics. We don't have natively Monasca plugin for SNMP. Yeah, Ceilometer or...
Okay, and so what kind of services can you get metrics from, like databases?
Yeah, we have plugins like for my typical databases, MySQL, InfluxDB, Postgres, RabbitMQ.
Last question is...
but
we're out of time for this session.
Okay, sorry.
Take it outside if you need more.
Yeah.
Let's stop.
Yeah.